Hello, I'm Nikolas Krisma Hadi Fernandez, and through this video, I will try to explain the heat transfer experiment for senior mechanical laboratory. So, this is the schematic. There are several objects here, which are the fans, the anemometer, two thermocouples, the one specimen, and one heater. So, we'll try to heat the specimen, and we'll measure the temperature on both this thermocouple, and we also will uh, measure the wind velocity from the fans here. So for the assembly, uh, so before that, all the objects that is stated previously are purchased from online shops and shipping to my hometown, because on this pandemic we cannot do the experiment on the campus laboratory. So for the assembly, uh, we made the wind tunnel so that the wind concentrated to the objects inside the wind tunnel. The wind tunnel itself is from a paper, and it is stick to the fans here. So inside it there's a heater, electrical heater, and this is the specimen that uh, that, that we use. So this is the specimen that we use, and these are the thermocouple. For the A side, the position A is the position where we measure the temperature that nearer to the fans for the specimen, and for position B, it is we measure the temperature here on position that further from the fans. So we we do three trials for this experiment. For the first trial, we measure the wind velocity. So we can see that the wind is actually fluctuative, and it is it is stable at around meter per second here. So most of the time the anemometer told us that the wind velocity is 1.7 meter per second. So next we'll measure the temperature. So we turn on the electric, and this is the initial temperature, and we'll measure it with the time interval of around 1 minute. So I will speed it up from now on. So we can see here the this is the final temperature where the T is equal to 60 seconds. So we move to the second trial, and we again measure the wind velocity. So it's the mode 2 on the fans. As you can see that the velocity again fluctuative, but it is stable at around 2.0 meter per second. So then we will measure the temperature. Again, before we measure the temperature, we will cool down the specimen. So this is the initial temperature at first. Again, on this side, it is the position nearer to the fan, and on the left side it is further to the fan. The time interval again 1 minute, and I will speed it up from now on. Now we can see that this is the final temperature of both position, and we have write it. And the third trial, again we measure the wind temperature and the temperature. We wind wind velocity here. I'm sorry. So this is the wind velocity. Wait, actually we can see the temperature is around 31.1. Again, this have highs and lows, but most of the time the anemometer told us that the wind velocity is around 3.1 meter per second here. So then we measure the temperature. Again, we turn on the heater and we see the temperature. This is the initial temperature. This is the temperature on position further from the fans, and this is the position nearer to the fans. Again, the time interval is 60 seconds, and I will speed it up from now on. And we can see that this is the final temperature for both positions. So after we done the experiment, we'll take all the data, the time interval, the temperature on each position, and the wind velocity. So these are the data obtained from the experiment. This is the first trial, second, and third. This is position A, which is the position nearer to the fan, and this is position B, A, B, A, B. The B is position further to the fan. This is the wind velocity, and this is the initial temperature for each position, the final temperature, and time interval, which is around 60 seconds from initial to final temperature. So from this, we can do the graph, and we can see that the average temperature change per second for each position. The blue one is the position A, and the orange one is the position B. This is the wind velocity. So for each of the position from the first and the second trial, it is picked up. It may because the first trial is it has different some different environment from the second trial, because on the first trial the heater is still on cooling, so it's still on the around room temperature, and it is heat up, so the specimen may be take a lot sometimes to change the temperature. However, from 2 and 3 we can see that both position is lower, so the wind velocity from the first, second, and third trial uh, does affect the average temperature, which the higher the wind velocity, the lower the average temperature change. The second and third, I can say that the environment is very similar, which the heater is already heated, even the specimen is cooled down, but the heater is already heated, and it may give some temperature change before we even take the data. So from the experiment, we can see that the wind velocity actually affect the average temperature change of the specimen. The higher the wind velocity is, it actually will lower the average temperature change. For the first and second uh, trial, it may not, it may, it may not correct because the environment is not exactly the same. It's not similar maybe. That's why the average temperature change is lower on the first trial than the second trial. So that's all for the experiment. For the course feedback, I don't really have the feedback for the course because it's already great. In my opinion, it's already good and challenging. It's fun that we plan the experiment by our own. We plan all the objects that we will purchase, and we will plan what will we do with the objects. It is fun and it's different with some other experiment that we have done before, which we only follow the step or the methods that other people do. From this course also we can learn many things, which we must choose the sensor, we must choose the specimen, etc., and the variable that we will compare, etc. So that's all from my video. Thank you very much.